Are we recording? We are. We are recording. Welcome back. Welcome back to the rack. Today is a special day. We announce the pre-release of my first ever VCV Rack 2 plugin called DataWave. Oh, we're still going. We're still going. Okay, more fanfare. It's on GitHub. You can click on the releases, and there should be a version for Mac, for Linux, and for Windows. The name of the repository is Edge of Chaos. Yes, more fanfare! Edge of Chaos. DataWave, bringing you the finest and random numbers, the finest numbers that money can't buy. Okay. So, yes. So I've got this repository called Edge of Chaos. That's the name of the plugin, but the plugin only contains one module, and the module is called DataWave. And yes, it's a pre-release. It's a beta for testing. I'd like you all to test it, try it out. Let me know. Tell me what you think of it. See if you can find any bugs or problems with it. And yes, that would be great. So let's get back into the rack. Here we are. And the first things first, let's pop one in. Oh, there we go, DataWave. So there it is, looking fresh, all the new graphics and stuff. And so this video is gonna serve as a form of manual, because I am not gonna write a manual. At the moment it's just gonna have to be a video. And we're just going to run through how to use it, what all the inputs and bits and bobs are on there. I mean, you can put the tooltips on, and it does kind of tell you reseed, input, seed, mode, offset, scale, etc., etc. And I'm going to first cover the most common use case scenario, which is using DataWave to generate melodic sequences. I mean, yeah, what is DataWave? Yeah, for those of you who don't know or haven't seen some of my previous videos, DataWave is a generative sequencer of sorts that can be useful for making melodies, phrases, melodic phrases. It can also be used to make rhythmical phrases, and it's a good alternative to your common garden LFO, low frequency oscillator thingy. So yeah. I guess in a way it could also be seen as a sort of arbitrary waveform generator again. Well, not arbitrary waveform, probably arbitrary control voltage generator, or arbitrary LFO of sorts. Yes, we will take a look anyway. So let's pop some bits in. So I'm going to just pop a scope in just so we can see everything that's going on, and I'm going to connect the output of DataWave into the scope. Oh, not with grey, I'm going to pick a nice color. It should be blue or cyan. There we go. So we've got a nice reading on the scope there. I'm also going, yeah, so the first use case would probably be let's get a VCO. I like the wavetable one. Let's just pop that after the scope. And we're going to, well, first of all, let's just connect this to the output and have a listen. Magical. Okay, that's working. And then we're also going to take the CV and plug it into the pitch input here. Now, initially, nothing will happen. And that's because we need to clock the data wave in order for it to output values. So it won't output values. It does very little at all until you stick the clock input in. So I'm just going to create a clock module, or go grab a clock module. So there's this nice one from AS. So I'm going to take the 16th note output and shove it into the clock. Oh, my cables are changing color. I didn't want them to do that. Right, so yeah, you can see it's now spewing out values. You can see them on the scope, and in terms of pitch, that sounds like this. Awful. So it's obviously a massive range of different values. So there's a few things that we can do to massage this. One thing would be to change the scale. So instead of a scale of 10, which in a 1 volt per octave input would mean a range of 10 octaves, which is insane. So let's just crack that down to, say, 2 octaves. So I'm just going to right mouse button click on it and set it precisely rather than just squiggling the dial. And now we've got this. Cool. And then we also want to confine this to a useful scale, musical scale. So I'm just going to get the quantize plugin, the quantizer, and we're just going to take the output from the DataWave. I'm going to stick it into the pitch input on the quantizer, and then the quantized pitch output. Ooh, yeah, this is going to irritate me, changing colors of the cables all the time. I'm going to plug it into the pitch input on the oscillator. And just a bit housekeeping, I'm going to just create a cable palette thing just so I can lock the gray cables so we don't have lots of brightly colored distracting cables floating around. There we go. So now if we turn it up, we should have something that's somewhat musical. Well, sort of. I mean, at the moment we're a bit chromatic, so let's just remove all these white notes and do something pentatonic. Great, and that's already better. So yes, so we've had a look at the offset and scale. I'll just demonstrate those. So if we can even turn the frequency down on here, and then the scale. Okay, so I mean they're probably a bit too low. Hang on, let me just go down. I'm going to right mouse button click. I want to get a precise frequency here, so I'm just going to divide by 2 just to pop the oscillator down an octave, and then we're just going to scale to 2 octaves, offset 0. There we go. That's more usable. So you can see if we want to jump up an octave, we could just use the offset. Like that, and then obviously if we put that back to 0, jumps down an octave. I mean, that's useful because these CV controls are proportional to whatever value you've got set here. So if we, for example, put in an LFO and connect the square wave output from this LFO is unipolar, so it's outputting voltages between 0 and 10 on the square wave output. And if we just jam that into the offset, and then we set the offset, well, if we leave the offset at 0, it should have no effect. So same as before. And then if we put the offset to 1, hang on, let's observe this on the scope. Slow it down a bit. So you can see here on the scope that whenever the LFO goes high, we jump up an octave. And if we want, we could jump up 2 octaves. So let's change the offset to 2. And obviously we could use any shape, so we could try a triangle. Try a triangle. Do try a triangle. Triangles are great. You should try them. Then you can see how it's affecting the output here. You can see the stepped values are sort of rising up and down. So yeah, so that's how you can use the control voltage inputs for the offset or the scale. So yeah, that could be useful. And what else do we need to do? I think that's it for that for now. For now, that's okay. So let's just move you out of the way. And next, we need to look at the seed. So in order to get the seed value here to do anything useful, we need to start reseeding. We need to plug something into this input here. Now, reseeding, think of it as resetting or going back to the top of the bar. So you're basically telling it that you want to repeat the phrase again. So I'm going to just connect the bar output from this clock into the reseed input, and it should now every bar it should just go back to the start of the phrase. So we should get, oh, there we go. So we've got a kind of looping going on, and we can change the seed and it should just pick another phrase. And you'll also notice that because we're re-triggering on the bar, that the seed, if you change the seed, it doesn't have immediate effect. If you want it to have immediate effect, you'd have to then pulse the reseed input. But the good thing about that is it waits till the top of the bar in order to change the phrase, so nothing falls out of sync. Okay, and you'll also notice there's so many values available for the seed that if on this little helper tooltip pop-up thing, VCV has resorted to using a mathematical expression in order to display the humongous values that DataWave is got available for its seed. So yeah, it basically yeah, it's just huge. There's just so many different phrases available. You could spend quite a lot of time listening to them, and well, you probably couldn't get through them all, to be honest. You'd probably drop down dead before you got to the end. If anyone wants to calculate that, if you're particularly nerdy, how long would it take? Yeah, so that's quite useful. And what we can do is we could set the seed with the CV input at the top here. Again, that's proportional. So what you could do, for example, is you could just say, I only want 10 seeds. So just type in 10. You can see that it barely moves the dial. And then obviously we could just put a random number in here. So we just go rand, select this 2x R&D, and then if you click on these buttons here, it basically just spews out random numbers, or again, it's got an external trigger, and we just shove that in there, and then every time I click this, it should pick one of, actually let's just limit this to 3, and then there should only be a couple of phrases, 3 phrases available, phrases or seeds, essentially the same thing here. So here we go. Let's pick the same one and then do it again. Come on. There we go. So what we've done there is we've basically limited it to only having 3 seeds. But normally what you do is just crank that up, and then it would pick from a list of incredibly long list of seeds, which means that statistically it's hugely improbable that you'd get the same phrase twice. Here we go. Click it again, it should be different. Click it again. Brilliant. I mean, this is such a common thing to do, to just randomly generate a new seed, that I've actually built it in. So it's actually built in here. There's this other input here is the gen seed input. So you just put a clock pulse or something in there, and it will spew out a new seed for you automatically. So a common scenario would be clocking it at a high rate, then every bar you're reseeding, and then after so many bars, you would then choose or generate a new sequence. So yeah, let's just put a clock divider in here so we can count the bars. So I'm just going to put in a regular clock divider here, and we're going to take the bar output into the clock, and then we're just going to say every 4 bars, can you just give me a new seed, and so you get a new sequence. And you'll see the knob actually moves to show you that it's chosen a new seed. So let's have a listen. Great, so straight away, it's a great way of generating little phrases for a specific length of time and then creating a variation. So, you know, you could create a generative composition using those sorts of techniques there. The next thing to look at is the slew rate control. So this is quite interesting when you've got the pitch quantizer. So you can create a kind of portamento effect. So and then this button underneath is a multiplier for the slew rate. So if you want super slow slew rate control, then you just multiply it by 10. You get 10 times whatever's set on this dial. So actually, I'm just going to turn this down so we can just see it visually on the scope. And I'm going to turn the scale right the way up so we can really see what's going on. Let's just change the time base a bit. Here we go. So you can see we're spitting out random values over a range between 0 and 10 volts. And then if we turn the slew rate control up, you can see it starts to interpolate between those points. Wow, that is a noisy moped. Silence! Okay, so here we go. You can see it's interpolating between the points, and if we crank it up, it's even smoother. And this is where we're getting into the kind of LFO territory. And obviously, if you wanted something much slower, then instead of clocking it at 16ths, I mean, let's just clock it at quarter notes, and then you could maybe turn on the multiplier for the slew rate, and there we go. We're getting much slower, smoother lines coming out, or values, yeah. And if you crank the slew rate really high, then basically it hasn't got time, it won't interpolate fast enough to actually reach the value, so you get this much kind of slower, meandering, moving control voltage, which can be quite useful for when you want to remove the sort of periodicity or the pulsing or the beat or the, you know, the kind of the regularity to the output. If you want to kind of remove that, you can basically just completely smoosh it out with the or smooth it out with the slew control, so you don't get these discrete steps at all, and you just get this kind of meandering control voltage, which can be useful for other kinds of parametric control as opposed to, say, controlling pitch. I mean, what does that even sound like? Oh yeah, nice. But a little bit on the pitch is nice because it gives you that kind of glidey portamento thing. Okay, so that is almost everything there. I think, yeah, that's all of how to do the seed stuff. We've looked at the offset, the scale, we've looked at the slew rate limiter and the multiplier for the slew rate limiter. So the last thing to look at are the different modes that we have available. So I'm actually going to take the generate seed input out because I just want to loop over the same phrase. And then what we're going to do is we're going to look at how the mode changes that phrase. So I think there's 5 different modes. So let's turn this up. And we'll move to the next mode. So this mode favors lower notes, or lower values, and the next mode will favor higher values. This mode favors values or notes in the middle of the range. And this last one favours notes at the extremes of the range. And then back to the start. So you can hear we've actually retained our phrase there, and it's sort of created variations for us. And depending on what sort of phrase we want, the different modes can have different kind of musical applications. So it just, if you want to know, the cyan mode is uniform randomness. The magenta mode is inverse linear. Yellow is linear. Green is triangle, as a triangle distribution, and then white is an inverse triangle. So those are the different modes that I've provided for it. And yeah, so you don't really need to know any of that stuff. You just need to pick one that you like, basically. But uniform is what we're used to hearing, and it's sort of constantly jumping around. It's got less of a sense of structure to say something like for example, the green one really feels like it has a tonal center because it's sort of hovering around one particular place. Let's just pick a different seed, hang on. Yeah, so they've got their different uses, basically. And again, you can control that from with a control voltage, 0 to 10 volts, and the little light will change, and that's very nice. Okay, so that's the primary use case I think that most people will be interested in. So that's how you could make melodic sequences or phrases using DataWave. And I think, yeah, we're just going to quickly look at another application, and I'm just going to delete the clock divider. Actually, we don't need that. Oh, actually, no, that might have been quite useful. Oh no, we don't need it. Let's just disconnect everything. So I'm going to do hover command U, unconnect, and I'm going to put in another kind of clock divider. This one's a special one, again from the wonderful people at SynthKit. This one is a shifting clock divider with a CV input. Ooh, very nice. Oh look, it's the same size as DataWave. Oh, hang on. So is the quantizer, isn't it? Is the quantizer... Oh no, the quantizer is skinnier. Ah, damn, that would have been too coincidental. I mean, the modes doesn't matter in this case. Oh no, it does actually, and that will be interesting. We'll get to that in a moment. But what we're going to do here is, what you can see is, I mean, if we just treat this as a normal clock divider, we would put the clock in, and you see the output start flashing away, and then we've got different divisions here. So we've got half the speed, quarter of the speed, 1/8 of the speed. So basically at the top we've got the output flashing away really fast, and at the bottom it's much slower. And then what we can do is use the same clock to drive our DataWave, and then we're going to take the output of DataWave and we're going to use that to shift the clock divider. So what that does is it basically jumbles up the outputs. So, you know, if I just turn the scale all the way up and the offset all the way down by double clicking on them to reset the values, you'll see now we've got a kind of pattern pulsing on all the different outputs. So, you know, what was once the divide by 1 is now suddenly the divide by 4 or the divide by 5. And that allows us to create rhythms. So I'm going to pop in a PCM drum, which is this basic sampler drum machine thing, which comes preloaded with a bunch of Lindrum samples, which is really useful for us. And I'm just going to take the first output here, pop it in the trigger, and then go straight to the main output, and then we're just going to turn it up a bit and we should get a rhythm. And again, like before, we can take the bar and reseed, so now we get a more consistent rhythm. And then again, we can just change the seed to get a different rhythm. And again. Great. And what we can do is we can actually limit the divisions that we go to. So if we want something a bit faster, so let's say we only divide by 4 at the most. So let's just, you can see the control voltage markings at the side. That one is 3.5 volts. So let's just change the scale to 3.5. Then we should get something a bit faster. So we only get the... Is that right? Oh, it was already doing that. That's weird. Oh, you have to go much lower. Oh, I think it's because we had it on 10 volts, didn't we? And it tops out at 7.5, so it was probably wrapping round. Yes, it's wrapping round. But yeah, for example, if we put it to 1.5, then we should... we don't get any divisions. Let's go above that. What's 2.5 like? Oh, here we go. It's starting to bring in these other divisions now. Yeah, cool. I think about 3.5 sounds good. Okay, so that's how we can create rhythms. What's interesting, what can we do with that? Oh yeah, so again, if we change the mode, if we go to the purple mode, we should get more of the faster yeah, we get more of the shorter divisions. Yeah, and I think we're also going to take the output. We could actually stick another DataWave in and use that to drive or select the sample. So if you connect it to this input here on the PCM drum, it will change what sample it's playing back. Yeah, so we could do that. And again, the great thing about that is because we're using DataWave, we can actually have a sequence to that, even though it's randomized. So it's playing the same drum hits at the same time and has a sense of phrase. So what we're just going to do is we're just going to borrow this output from and control the sample as well as the rhythm at the same time. Oh, I mean, that could be interesting, even more interesting, because there's then a relationship there, isn't there? And you can just change the bank as well, the bank of samples. And now if I change the seed, we should get a different beat. Or we could change the mode. Yeah, the purple one's quite a good mode for the drums because it tends to favour the kind of shorter time divisions. But again, you can control that a bit by moving the scale. And what another interesting thing is we've got all these different outputs that are flashing slightly different rhythms, so we could just copy and paste, duplicate that and just take a different output and trigger that, and then it shouldn't really be playing them at the same time, or it shouldn't be playing the same rhythm. You can see they're flashing differently, which could be useful. So let's just pop in a little mixer, mix, a mixer. What do we got? Mix. No, I don't want a Unity mix. I want to be able to change the levels. Oh, this one's quite good. This one's a Unity mixer, but it has an overall level. Nice. So let's just turn the overall level down. Let's take the output, plug one in there, and then this is going to go to the main output. We can pull this volume down and put this one up a bit so we're not clipping. And then this one we're going to change to hat and crash or something. So it's just playing one sample. I mean, what we could do is we could take the CV and use it for the tune pitch. And let's just pick a different beat. go lo-fi. If you don't want to twiddle the knob, sometimes I like to just put in a massive button. I like this purple one because you can write things. And then we're just going to connect that up to the generate seed, or generate a new beat basically. And then if you stuck a kick drum with that, you'd be away. I mean, let's do that because yeah, you really get an idea of what's going on with the kick drum in there as well. So I mean, you know, you can use a kick drum with a 4 to the floor to anchor everything basically. So everything else is like, you know, generating and changing and bits going on, and then the kick drum is just anchoring everything. Ooh, the kids are out at school next door. Let me just shut the window on, hang on. That's one particular child that's just he just screams hysterically whenever they let him outside. Okay, so let's just take the beat, which should be quarter notes, and that should give us a 4 4 4 on the floor. The output, stick it in the mixer. It's not ideal because we can't plug it in because they're highlighted. Just unselect them. Let's do that. We're just gonna have to crank it up so we can hear what's going on with it, because I can't be bothered to mix anything. Who can be bothered with mixing, eh? Here we go. There we go, that's good tuning. Shorten it down, there we go. Banger, banger. Get some distortion on that, you'd be away. And then we just click and here we go. Oh yeah, cowbell for the win. And you just click and it just gives you a new beat. I mean, if you want to go crazy, you could reseed, you know, you could have longer phrases, reseed every couple of bars, or we could reseed every beat. Let's see what that's like. Oh, no, it's rubbish. Hang on. Right, I think that's time for me to end, because the sound of that distortion is the sound of my screen capturing software crapping itself because of the gain control, I think, on the audio and the mixing that it does. Yeah, so there we go. That ends our brief tutorial walkthrough of the DataWave plugin. Let's just disconnect it and pop it up here and look at it in all of its glory. So I hope that some of you will have a crack at this plugin and try it out. The people on the VCV Rack user group on Facebook, you've all been absolutely amazing. I really appreciate your time, and you've all been very kind. You've given me some great feedback. And if anyone wants to try this out, you know, be aware it is, you know, just a beta version for your testing and for your own personal uses, your own purposes. But you know, go out there, make generative beats, make generative melodies, try making chords, anything you like, and let me know how you get on. And oh yeah, and a special shout out as well. Let's do a special shout out. Let's do the Facebooks. You can all look at my Facebook and see what weird and wonderful things are going on. Here we go. VCV Rack user group. Oh, Jeremy Wentworth. Big up, Jeremy. Make some cool plugins. So there was here Mateus, I think. Sorry if I'm getting your name wrong. Big shout out. He's made some videos, which is amazing feedback because I get to see actually how you interact and use these things. And yeah, I can't thank you enough for doing that. That's amazing. It's really helpful for me because testing is, that's really what makes these plugins good in the end, is getting people to try them out and show you how they're used. Oh yeah, and if you haven't seen it, there's a nice video there of the doing a chord progression. I'm sure there's a more efficient way of doing it, but that was it works. It works. Yeah, so I'm going to leave it there. I've spoken. I have said too much. I've said too much.